Hey, logarithms aren't that hard, right? Well, things are going to get a little bit harder. Let's get into some laws of logarithms. So the essential question for today is, just what properties of logarithms can I use to expand and condense these logarithm expressions? So here's the deal. Just like we had exponent laws that we could use to get exponents together, we have logarithm laws. And the deal is that since logarithms and exponents are opposites, their laws kind of parallel each other. And I could show this to you in some pretty cool ways. I could do some proofs. I could give you a cool activity. I don't know. I just sort of feel like telling them to you. Just get them in your head. I'll show you where they are parallel. If you're interested in why these things work out, I can maybe show you something more in depth. So ask me about that. Anyway, first of all, exponent laws. Let's think about them. We had this law that said if I have two exponents, or if I have two powers of the same base, and these powers are multiplying each other, I need to add the exponents, right? Remember that law? Likewise, if I have two logarithms with the same base, which I'll call b, so let's say have this is confusing. Okay, let's make this an x. So log base b of x plus log base b of y. If I have two logarithms that are adding each other, I can write them as the same logarithm with the insides multiplying each other. So this is our first logarithm law. Notice how it parallels the exponent law. If I have two powers that are multiplying, I add the exponents. Here, if I have two logarithms that are adding, I multiply the inside. And the reason why this works out, again, there's a complicated explanation, but it's because really what logarithms are is they're exponents, right? Like they're solving the equation, what power of this gives me this. So they are exponents, so they behave sort of similarly with similar laws. Okay, let's do another one. Let's say I had something like x to the third over x to the 2. Well, then you would know to subtract the exponents. I'd get just x to the 1. Similarly, with logarithms, if I have two logarithms of the same base that are subtracting each other, then their insides are going to divide. And that should make a lot of sense. If they're adding each other, obviously they're going to multiply. Likewise, in a reverse manner, if the two logarithms are subtracting, their insides are going to divide. The last exponent rule we had was if I had a power to a power, so x cubed squared, I need to multiply those exponents. So in this case, it'd be x to the 6th. This parallel is kind of bizarre, but it's actually my favorite. Let's say you have something multiplying the logarithm. So let's say I have like k just being any number, log base b of x. What I can do, this is my favorite log law, is I can write log base b of x to the power of k. So basically what's happening here is this k that was a multiplier or a coefficient, it was multiplying the logarithm, I can take it and I can put it inside as an exponent. Pretty neat. So here are our three log laws. Definitely write these down. Let's apply them now. You're going to be asked to expand expressions. So for instance, this one. Right now what I have is this complicated dense expression on the inside. But I can expand the expression into two separate logarithms. How? By making use of this rule. Since I have two things in the middle multiplying, I can separate them, do log base 6 of 36 plus log base 6 of x squared. See what I did there? I had the multiplication and I wrote it as two logarithms adding each other. Likewise, since I have an exponent in here, what I can do is I can use this log law that says if I have an exponent, I can also write it as a multiplier. So let's do that in the second step. So this is log base 6 of 36 plus 2 times log base 6 of x. Now, as a final step, I should make sure that if I can simplify any logarithms, I can. look, this logarithm, what power of 6 gives me x? I don't know. That's just going to need to stay. But this logarithm, what power of 6 gives me 36? Well, that would be 2. Log base 6 of 36 is 2. So I have 2 plus 2 log base 6x. And I expanded the logarithm. Pretty cool. And it's kind of neat to know that this is equivalent to this, or at least I think it is. Let's look at the next one. Now, don't get freaked out by the ln. We know that this is just log base e, so it really is a logarithm. It'll obey the same laws. I didn't learn any laws about roots, but I do know that this root is the same as the fractional exponent 3 over 4. Now, since I have dividing inside the logarithm, we know that we can split it up by subtracting two separate logarithms, right? Then, just like what I did here, bringing this 2 down in front as a multiplier, this 3/4 as an exponent becomes the multiplier. So 3 over 4 ln x minus ln 4. Again, I should check to see if I can simplify any exponents, but like what power of e gives me 4? That doesn't make any sense. I'm not going to be able to do that without a calculator. So here is my final answer, expanding. Similarly, you could be asked to condense, much like, I don't know, much like putting your books on a book. I can't find a good pun. I'm sorry. So I need to be able to take these two separate logarithms and write them as one logarithm, and I'll kind of work backwards. First of all, take this 1/3, write it as an exponent, or if we're even cooler, let's use the fact that a 1/3 exponent is the same as a cube root. Just because I'm feeling like it. I could also write x to the 1/3. Now, since I have two logarithms adding each other, I can write them as one logarithm with multiplication inside, and I am done. See what I did there? Since I have two logs of the same base adding each other, I can take them and write them as one logarithm where the insides are multiplying. Pretty cool. Okay, next, I have two multipliers that I'll put up as exponents. So ln 2 to the 6th minus ln y to the 4th. Now 2 to the 6th I can actually comprehend, like 2 to the 6th happens to be 64. So I should simplify that. I'm writing my L's as cursive, which I learned to enjoy doing to avoid the flaw of thinking that the L was a 1. Maybe you'll follow me and do the same. Since I have two logarithms subtracting, I know that I can write these as one logarithm with division. Easy, done. Okay, now I have one more thing to teach you. Remember yesterday in class, I told you this. I told you, hey, there's a way our calculator can do this, but I need to teach it to you. Now, some of you may have found this button, but what I showed you in class was we only knew that the log button gave me log base 10, and we knew that the ln button gave me log base e. So how am I supposed to do problems where there's a log base 3 or log base 7? We have this amazing property, and it really is amazing, called the change of base formula. Here's what it is. If you have the log of some base, let's call it a, of x, and you need to do this into your calculator, what you can do is you can select a base. You can pick 10, you can pick e. If you're really clever, you can do other bases as well, and you can do this. Log base b of x, b being any base you choose, over log base b of a. And this will give you the answer. So now we can use our calculators. If we go log of x, this is log base 10, over log of a, that will give you the answer. Or we could choose ln as well. If we do ln of x, we could do ln of x over ln of a. That will give me the right answer. Notice the a was the base of the original logarithm. The x was kind of the inside thing of the original logarithm. All of these will give you the same answers. And if the numbers worked out perfectly, I could even choose like log base 2. Like you wouldn't want to do that in your calculator. I'm just saying like you could choose it. So let's take a look at this one. What I could do is I could do log 20 over log 3. This will give me the answer. And let me just pull out my calculator real quick from my drawer. And let's just do it. I'm doing log 20 divided by log 3, and I'm getting the answer of 2.73. I'm rounding. And test this out. This will actually be the same answer as if you had chosen ln. If you do ln of 20 over ln of 3, that will also give you 2.73. Very, very neat. So this is a really easy formula to use. You just have to remember it. Okay, log base 7 of 11. Again, in your calculator, I'll choose log 11 over log 7. I could have chosen ln 11 over ln 7. And they'll both give me the same answer. So just for kicks, I'll do the ln in my calculator this time. ln divided by ln, and I'm getting 1.23. This would have been the same as if I had chosen log, and you can prove it to yourself by pulling out your calculator and doing it right now. So change of base, easy. All right, so summary, logarithm laws. If I have two logarithms with the same base that are adding each other, I can write them as a single logarithm with multiplication. Likewise, if I have two logarithms subtracting each other, I can take them and write them as a common logarithm with division. Finally, if I have a multiple in front of my logarithm, I can write it as an exponent, so log base bx to the k. Finally, change of base formula. If I have something that I don't know how to do, say like this, I can write this as log b over log a. That will give me the answer. Or if you're feeling in an ln mood and natural logarithm mood, you could also do ln b over ln a. It'll be the same thing, which makes me smile. And I'm also smiling because the video has come to the close. Cool, man. Let's get out of here.